Hey everybody, it's Mr. Mott. Wanted to go over some quick notes on the structure of the atom. Okay, so by now you've got your packet, and you can open up to page 4 in your packet. This is where we're going to take some notes. What I'm about to draw now, you don't have to write down or anything like that unless you find it really compelling. It's a little history of the atom. So I'll let you know when you want to start writing some stuff down, and I'll take some notes on our page. Okay. So anyway, the structure of the atom. This is like the 2-minute version of the history of the atom. So long time ago, philosophers and scientists knew that there was something that there was something on sort of a small scale. Things were made of, and they came up with the word atom. Okay, and so a lot of different people hypothesized what the structure of the atom was, and one of the most recent things that was a real breakthrough with the atom was Rutherford. Okay, so again, you're not writing this down. I'll let you know, but this is sort of Rutherford's experiment. Okay, and what he did. So he wanted to know what the atom was made of, whether it was, they used to think it was one solid mass. And so what he did, he designed this experiment. So what he did is that he took a piece of, I believe it was gold foil, almost like aluminum foil. It was made out of gold. And he made kind of a shield here. And then he had some type of detector back here. So this is some type of detector. And the detector was going to see if anything got through. Okay, so this is kind of what he did, and then he had something where he shot these alpha rays. Okay, it's almost like a gun. Okay, so think about it, almost like shooting different particles through here. And so what he learned is that when they shot these like alpha particles through here, okay, so almost think about like a laser, for instance. And so what happened is that some of them went straight through. Some of these alpha particles went straight through. Some of them kind of deflected and hit in different spots here. Some of them, when they alpha particles hit, they actually didn't get through and they kind of bounced back. Or they didn't get through and they kind of bounce off to the side. Some of them went a little bit more of an angle here. And so the fact that some of them went straight through without being deflected off, and then some of them didn't hit their target straight on, kind of meant that in an atom there was some sort of solid pieces to it, and then there was also some empty space. And so that's where we kind of come up with the structure of the atom. And so the modern interpretation on a very basic scale of the atom is that you've got a nucleus, okay, and it's got protons in the center, and it's got neutrons, okay? So protons and neutrons in the center, and I didn't write my nucleus very big, and then you have electrons that are on the outside. Now, without going into too much detail about it, that's the general structure of the atom. So what we're going to do now is we're going to take a few notes on the structure of the atom, some different properties of protons, neutrons, and electrons. And we're going to then talk about how do you find those out. So go ahead and we're going to take some notes on your Cornell note sheet of paper right now. Okay? So here we go. We've got our Cornell notes, and we have our title of our lesson 12 is about the atomic number and the atomic mass. And so our topic is going to be structure of the atom. Okay, it's going to be structure of the atom there. And then our essential question, which we're going to end up getting to, is how can we use the periodic table to determine parts of the atom. Okay, question mark. How can we use the periodic table to determine parts of the atom? All right, so first of all, this is going to be like a little bit of a background. Okay, so so first of all, we have protons. Okay, so our question off to the side could be, what is a proton, or what are some properties of protons? So actually what I'm going to do is I'm going to list out here, make a little chart here. Proton, neutron, and electron. Okay, I'm going to make a little chart here, give ourselves some space. So proton, neutron, electron. I'm going to go across here, and so first of all, I'm going to write location. Where are they all located? All right, so I'll draw a little line across here, and a line across here, go here. All right, so we saw that the protons are in the nucleus, neutrons are in the nucleus, and then electrons are outside the nucleus. Okay. All right. Each of these parts of the atom has a charge that's associated with it. Okay. And so protons have a positive charge. So I'm going to write a plus sign. If you want to write the word positive out, you can. Neutrons have zero charge. Okay. They have zero charge. You could write a 0 or write the word like I did. And the electrons have a negative charge. So I'm going to write the minus for a negative. And I'm going to write the word. So you write down whatever makes sense to you. So protons and electrons have that negative charge. And then also we're going to talk about what their mass is. Their mass. Now, the mass of a proton is super, super tiny, and so we can't describe it in grams. It'd be a number that's so small it wouldn't be meaningful to us. So what we've got is it's almost a relative mass. Protons and neutrons have a mass that are pretty much equal to each other. The electrons are really, really small, even in comparison to protons and neutrons. So they have a mass of like 1 over 2,000, 1/2000th the mass of a neutron or a proton. So these are all kind of relative amounts. They actually describe them in a unit called the atomic mass units. But for our purposes, know that the mass of a proton and neutron are the same, and electrons have a very small, almost zero charge. Okay. So that's important to know about the protons, the neutrons, and electrons, some different properties about them. All right. What else do we need to know? All right. This is a little bit of knowledge that we're going to need a little bit later. When we use the word atom, atom is going to convey that the number of protons and electrons are going to be equal. So we're going to use that word atom quite a bit. Okay, protons and electrons are equal when you're talking about an atom. One word that we're going to use a little bit later is ion. When you have an ion, the protons do not equal. Okay, so this symbol means do not equal. If that looks really weird and you've never seen that, go ahead and write protons and then use the words do not equal electrons. Okay, we're mainly going to work on the fact that atoms right now, talking only about atoms. Okay, now it turns out that when we came up with the periodic table, that we can figure out the protons, neutrons, and electrons from the periodic table. So I'm going to use the example of lithium here, and so we're going to kind of draw out what you would see for lithium. Okay. All right. So lithium is a symbol Li. Okay. So switch the pink pen here. This pink is fun, right? So lithium is atomic number 3. and the mass is about 6.941. Okay, that's what it says there. So I got these numbers on here. This number 3 is known as the atomic number. Okay, and so what the atomic number tells you is the protons. All right, I'll give you a second to write that. Now, so that's the atomic number, and no other element has this atomic number, and likewise, no other element has 3 protons in its nucleus. It's actually the way that we identify what we're looking at. This number here at the bottom is the atomic mass. All right, and the atomic mass is going to be the protons plus the neutrons. Okay, so if you remember from the top, when we looked at our chart here, the masses are, if you were to add up all the protons, neutrons, and electrons, if you knew the protons and the neutrons, you add them up, you would need a whole lot more electrons for them to add up to anything. Their mass is almost 0. So the atomic mass is actually just going to be, we'll tell you, the protons plus the neutrons. Okay? So that's why we have the atomic masses, the protons and the neutrons. The electrons don't really weigh much, so we just kind of ignore them. Okay? Now, if you want to know from this how many protons, neutrons, and electrons, we have all the information we need. The atomic number tells you protons. Well, if I'm dealing with, we can maybe write at the bottom here. I'm going to zoom out, okay, a little bit. Now, if I want to know how many protons are in this, I know that there's 3 protons because the atomic number is 3. If I want to know the electrons in this atom, well, the protons and the electrons are the same in an atom. Okay, so that's 3 as well. Okay, so we know that. Now for the neutrons, we've got to do a little math. Okay, it's not a big deal though. Don't worry, don't stress out. Okay, so for the neutrons, what you're going to do is, if the atomic mass is protons and neutrons, if we subtract the number, if we take the mass minus the atomic number, we should end up with only the neutrons. Okay. Now, one thing that we're going to do ahead of time, though, is that we're going to take the 6.9 number, we're going to round it to the nearest whole number, which is 7. Okay? And we're going to subtract 7 minus 3, all right? And we're going to get 4. So we have 4 neutrons here. When we return in class, we're going to go over is how do we figure out why is it 6.941? We're going to talk later about isotopes and that sort of thing. Okay? So from this, we should be able to figure out, we should know some different parts of the atom. We should know where all the different parts are located, what kind of charge they have, and their relative mass. The next thing I would want you to know from this is how can we use the periodic table to give us some of that information. Okay? So you're going to practice then on our next worksheet, find the total number of protons, neutrons, and electrons on the next page here. All right? So I'm going to have you guys work on page 6 in your packet. Okay? And so you got some of the information here. All right? And kind of work backwards. All right? And one thing that you'll need is that we have the element name like beryllium. We're going to need to know that the symbol is Be. Fluorine is F, and some of the other ones you're going to have to work backwards from. Okay? So in this case, for beryllium, the symbol is Be, like I just mentioned there. It has atomic number 4. Okay, that's that smaller number there. If atomic number is 4, the protons are 4, right? And since we're dealing with an atom, the protons and the electrons are the same. Okay? And so they give us the number of neutrons. If we needed to figure out neutrons, we would take, for your neutrons, you would take the mass minus which one? Mass minus protons, right? So to find the number of neutrons, it's going to be the mass minus, you can either say the atomic number, all right, for the number of neutrons. All right, so we're going to work on this right here for your homework. All right, I'll be back next class. You got questions?